Hello, this is Sevan Amdani and you're watching Sevan Amdani on YouTube. We are looking at the universe's oldest and most distant galaxies in more details than ever before.
Everywhere we look, there's galaxies everywhere.
NASA on Tuesday released the first set of color image captured with the $10 billion James Webb Space Telescope, more than 6 months after it was launched into orbit.
Tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
These first images that NASA has given us really are meant to demonstrate Webb's incredible capabilities in terms of scientific observations.
But how did Webb capture these first of their kind images? And what could they tell us about the universe and the life beyond our planet? This is today's topic. Named after a former NASA administrator, the James Webb Space Telescope is 100 times more powerful than its predecessor, the Hubble Space Telescope, which has been orbiting Earth and taking pictures of distant stars for over 30 years. Much of Webb's power comes from its massive primary mirror, which is more than 21 feet wide, giving it more than 6 times the light collecting area than Hubble has.
A telescope's sensitivity, basically how much detail it can see, depends on the size of the mirror area. Because the more light a telescope's mirror can collect, the more able it is to see objects in finer detail that are farther away.
Webb is situated about 1 million miles away from Earth, where it can get a clear view in details. It also has a sun shield that protects it from external sources of light and heat like the sun, Earth, and Moon.
Because Webb is operating much farther from Earth than Hubble is, Webb ultimately does have higher observing efficiency.
It also sees the universe differently. Many telescopes are designed to primarily capture visible light, which represents only silver of the spectrum of light emitted by stars and other celestial objects. In contrast, Webb captures a range of infrared light that is invisible to the human eye, but make up much of the light that comes our way from the universe.
We're looking at some of the sort of faintest stars, and earliest galaxies in unprecedented detail, and Webb will also help us probe these planets outside of our solar system known as exoplanets.
Scientists can study these exoplanets by measuring the intensity of light at different wavelengths and turning it into a graphical representation like this exoplanet spectrum released Tuesday.
That's really what enables us, hopefully, to sort of peek into the atmospheres of these exoplanets and ultimately maybe find one with a similar atmosphere to ours.
Scientists are specifically interested in presence of water or methane because those could indicate there was or is life on those exoplanets.
One of Webb's main scientific objectives really is to help us look for signs of life on other planets outside our solar system.
Images like this deep field observation captured by Webb will also help scientists study the development of celestial objects in the universe over time.
They help us resolve the details of fainter objects like stars and galaxies that were born much closer to the Big Bang than some of the other ones that perhaps Hubble can see.
In the 32 years since it was launched, Hubble has taken more than 1.5 million photos and helped extend our understanding of the universe. While the Webb mission is expected to continue for 20 years, scientists are hopeful that it will provide new insights about the formation of stars, galaxies, planets, and perhaps the presence of life.
NASA has many telescopes, but I think James Webb, for various reasons, has really captured the public's attention and imagination, and I feel like people are really rooting for this telescope and what it can tell us.
Now, the most important thing, the signs of water.
We are seeing the first full-color images.
Light from other worlds. It's astounding to me.
NASA just released the first image from the most powerful telescope ever built.
Significance of this moment, the dawn of a new era.
This one is the deepest we have ever seen into space. And this one is incredibly clear view of stars being born. But this one is very interesting. It might not look so pretty, but it is the most exciting thing, and I'm going to talk on it because this is how to find aliens.
From a tropical rainforest to the edge of time itself,
Billion-mile journey.
It's a planet, but not one in our solar system.
James Webb begins a voyage back to the birth of the universe.
Give us the best view of worlds beyond our own solar system.
We are not alone.
These are all the planets we know about
Outside
our solar system. And here they are in 3D. It's very exciting. So there are about 5,000 of these exoplanets, probably way more. This column right here is where we pointed the Kepler's telescope. Just imagine how many we find if we stayed anywhere else for long enough. This map is incredible because this is a decade of scientific work and huge leaps forward in technology. But when we look at it, this is floor plan of our cosmic house, and as far as we know, there is no one else home. So that's why it's said, enter the James Webb Space Telescope. It's hard enough to look at one of these tiny spots that there's even a planet and or maybe something else. So how does this telescope do it? If we looked at Earth from very far away, you couldn't see people obviously, and you can't see cities, no lights, even we can't hear their voices also. But if you could tell that our atmosphere has 78% of nitrogen and 21% of oxygen, so you know that you had a very good shot that there might possibility there's a life. But in putting on nitrogen and oxygen is not the only criteria for the existence of life. So those indications of lives are called biosignatures, and James Webb Telescope has the ability to find them on other planets. When a planet passes between us and their star, they cause a tiny dip in the starlight. Measuring those dips help us lot these planets in the first place. But a planet doesn't block all the light. In fact, a little bit passes through the atmosphere on its way to us. And different gases in the atmosphere block different kinds of light. And the James Webb Telescope is powerful enough to see what's missing. This is not very simple, obviously, but it sounds simple. But what's happening here is astonishing. This isn't the scale we are talking about, or this tiny specks of light in the depths of space. The scientists behind the James Webb Telescope chose to point it into these depths head first. So if we check the negative 47, 1.04, this one in the right spot where there is the vast 96b. This is an artist representation. Light left it 1150 years ago and just arrived to our new telescope, and it looks like this. From the kinds of light that block the tops of these specks, we learned that this planet's atmosphere has water. This doesn't mean that we found life. VAST 96b is a gas giant. It seems to have water vapor in a hot, steamy atmosphere.
We're not looking at liquid water here, but we're looking instead of at sort of steam, water vapor.
We found water vapor on other planets too, but we could only look much closer to Earth, only a couple hundred light years away. The fact that we have this much detail about a planet over 1,000 light years away, it's hard to articulate how insane this is. Just think about how much further we can search now.
Again, the first exoplanet data from Webb, so there's a lot to come.
This is the proof of concept. We know that this way of searching works. This is just a beginning. You know, since we were kids, we always wanted to discover life on another planet. But what this telescope made us realize that we are alive right now at one of the most exciting moments in the scientific history. Space is the final frontier. We are right now seeking out new life and new civilizations to see what no one has seen before. And it's not science fiction, it's actually the reality.